and then you can introduce him again.
I can't possibly repeat
Well, it's
that.
nice to be here with you guys tonight. I'll see you. I'm going to sign off.
All right. Okay, I've got my eye on the Facebook thing, and I think it's about to fail again. So it'll either work or it won't. All right, I'll keep trying, Jeremy. I know you've
Okay.
got people going there.
Yeah,
So
no problem.
I'll keep trying as you do your talk.
Yeah, no problem. Well,
All right.
thanks a lot for having me. Yeah, I'm relatively new to the GAAC club and to astronomy, I guess, as a hobby in general. It was only, I think, 3 years ago I got my telescope. So I'm not by any means a comet expert, but I put together some info. Hopefully it's interesting, and I got lucky enough, I think, to get some good images of the comet, and that's probably the main thing I want to share. So I can start my presentation. Let's see here. Okay. Can you see that?
Yep. I can see it.
Yep, we're all set.
All right, let me start it. Here we go. All right.
If people go to the upper right-hand corner, and if you're seeing anybody but Jeremy there, you can click on speaker view and get everybody to go away except him. So go ahead, Jeremy. Sorry.
No problem. All right, so I'll just start off with the basics. So what is a comet? A comet is an icy small solar system body that, when passing close to the sun, warms and begins to release gases in a process called outgassing. This produces a visible atmosphere or coma, and sometimes also a tail. These phenomena are due to the effects of solar radiation and the solar wind acting upon the nucleus of the comet. Comet nuclei range from a few hundred meters to tens of kilometers across and are composed of loose collections of ice dust and small rocky particles. The coma may be up to 15 times the Earth's diameter, while the tail may stretch beyond 1 astronomical unit, which, by the way, is just the distance between the Earth and the sun. If sufficiently bright, a comet may be seen from Earth without the aid of a telescope and may subtend an arc of 30 degrees across the sky. And then there's this graphic on the right here to show the difference between comets, asteroids, meteoroids, meteors, and meteorites. And I remember just back a few years, I was kind of hazy on this myself. So this is just there for your reference. So the nucleus, there's basically four parts to a comet. The nucleus, which is the solid core structure in the center, and it's composed of rock, dust, water, ice, frozen gases, and so it's commonly called a dirty snowball. The coma is the result of the dust and gas being released, and it forms this very large, thin atmosphere around the comet. And then the dust tail is literally the tail of dust left behind the comet. And this is kind of an interesting point in combination with the ion tail, where the direction that they point isn't totally intuitive, or at least it wasn't to me at first. So the ion tail is just the result of gases, the outgassing, that gas being ionized by the solar radiation, and it's always pointing back in a straight line. So if and this graphic on the right is just showing some stuff about Comet ISON, and it kind of describes some of what I'm talking about here. And then this graphic, I remember seeing this some time ago, but I managed to find it. And this is showing how the ion tail, which is the blue tail, is always pointing at the sun. So it's kind of interesting that the comet could be moving away from the sun, and the tail is still pointing away from the sun. So it's kind of interesting. Same with the dust cloud, or the dust tail. It's just that the dust tail, I guess, being more massive than the gas particles, tends to bend or arc towards the orbit of the comet. So it's just kind of an interesting thing. might be neat to, if I had a time, I would have tried to find an animation, but you get the idea here, I guess.
Gas and tail points straight away from sun. Dust tail curves.
Yeah, and I was fortunate enough to be able to capture both the ion tail and the dust tail. And then some other sort of terminology and facts about comets. The perihelion, that's often associated with the date of a comet, like when is it, when was its date of perihelion? That's just the point of closest approach to the sun of any object really orbiting around the sun. And then of course the magnitude, which you're all familiar with, but it's the apparent brightness, and it's on the same scale that we measure stars, planets, DSOs, galaxies, etc. And you know, an interesting thing about the magnitude scales, it's logarithmic. So you know, something that's going from 2 to 4 or is not twice as dim, and it's also kind of reversed from what people might assume. So a negative magnitude is actually brighter than a positive magnitude. So and you can see on the scale down there some common objects that you might be familiar with and where they sit on the magnitude scale. Many comets are tracked, and many, I guess most, really require telescopes or some kind of optical aid to observe them. And my first and only other observation was a comet was 46P Wirtanen on December 18th, 2018. And I believe at that point it was a magnitude 6. So it was quite faint. I certainly didn't notice it looking up at the sky. I had to kind of hunt for it, and I found it in my telescope. And that chart on the right is just showing in the month of December in 2018 all the comets that were kind of tracked that month. And one thing that popped out was Shoemaker-Levy 2, and I thought, wow, did I miss the Jupiter impact or something? But it was Shoemaker-Levy 9 that was the comet that impacted Jupiter. So I was glad I didn't miss that too that month. Again, I'm new to this, so I just, you know, I know I'm missing some things going back even just a few years ago. So yeah, next, well, I figured I would show what I captured on 46P Wirtanen. I took 1 minute exposures, all consecutive right in a row, ISO 1600 with my DSLR on my telescope. So it's roughly a 2 by 3 degree field of view. And the mount was just tracking at the sidereal rate. It was just tracking. I was actually guiding on a star, so you could see the motion of the comet against the stars. And my setup there is, it's basically the picture on the left is more or less what I was using at that point. And I'll just play this. Hopefully it will play. So you could see clouds coming through, and it was just really neat to see the motion across the stars. It just made it very real to me once I strung those individual exposures all together and saw it actually moving against the stars. So I guess when I heard about Comet Neowise, I thought it would be great to be able to do the same thing. And then just some other comment. I guess when people think of comets, they think of the great comets, or the ones that are visible to the naked eye. And these two are probably the most famous ones of recent years, Halley's and Comet Hale-Bopp. Halley's is a short period comet, which means its orbital period is less than 200 years. And Halley's comet's roughly 75 years. The first confirmed sighting was in 240 BC, but it really wasn't until 16th century when Edmund Halley managed to see three of the passings. Actually, does that make sense? 3 passings. Something seems a little off on that, but anyways, he managed to just by making those observations, he was able to, and talking with Isaac Newton, and all around the time where his laws of motion were coming into popularity and general knowledge, they were to kind of able to put that together to make the connection that it was really the same object. So I guess that's really why he was credited. His name is attached to that comet. Of course, the last sighting was in 1986, and there's an image of it, which I would guess would have been a film exposure at that in that year. Then Comet Hale-Bopp is a long period comet, so it's 2,500 years approximately, discovered independently on July 23rd, 1995 by two different observers, Alan Hale and Thomas Bopp, both in the United States. Initially, the comet had an apparent magnitude of 10.5 and lay near the globular cluster M70 in Sagittarius. And then finally, we get to Neowise, which I did learn a little bit here too. I wasn't initially aware of how it got its name, but it's a long period comet with a near parabolic orbit. It was discovered on March 27th, 2020 by astronomers using the Neowise, or using the WISE space telescope on the Neowise mission. At that time, it was an 18th magnitude object located 2 astronomical units away from the sun and 1.7 astronomical units away from Earth. So WISE it stands for the Wide Field Infrared Survey Explorer, and that's a picture of it up in the upper right. It was designed as an infrared telescope to perform all sky astronomical surveys in these various wavelengths over 10 months using its 16-inch diameter objective or mirror. After its hydrogen coolant was depleted, a 4-month extension called Neowise was conducted to search for near Earth objects, hence the Neo in Neowise. So it was able to find this comet. Apparently it's a 6,700 year period, at least outbound, and the nucleus is 3 miles in diameter. And then I found this is all on Wikipedia, but I thought this was interesting, this animation. So you'll see in the center, there's this, the center dot, or not quite the center, but that's the sun. Obviously we have then Mercury, Venus and in yellow, Earth in blue, and Mars in red. And if I play this, it'll show Comet Neowise in purple, and it will show these vertical lines that represent its position below or above the ecliptic, or the plane of all the planets. So I'll play this. I'll probably play it a couple times, and it's giving you a timestamp on the top and giving you the speed and the distance on the bottom. So you can watch as it approaches, the speed is increasing up to 77 kilometers per second. And you can see how everything is moving. It's just really cool to see that animation. And I believe, I know the top, I think 70 kilometers per second might be like 170 or 180,000 miles per hour. So it's moving quite quickly. It's not as quick as our fastest Explorer type spacecraft or probes, like the Parker Space Solar Probe I think is going over, I don't know if it was 200 or 400,000 miles per hour, but it's not moving that quickly, but it's still moving quite fast. And so by early July, Comet Neowise had brightened to a magnitude 1, far exceeding the brightness of these previous comets mentioned. It had also developed a second tail. The first tail was the ion tail, and then they're also mentioning high amounts of sodium in the second tail, which is mostly made of dust. Again, it's the dust tail, and it's very, very similar to the tail of Comet Hale-Bopp. And there's some debate, I guess, as to how bright did it actually get, because it was kind of passing near the sun, and the British Astronomical Association said that it would have gotten to -2 in early July, which would have made it brighter than Hale-Bopp. So I guess you could, either way, I think this is probably considered a great comet because it was visible naked eye. After perihelion, the comet, of course, began to fade, dropping to magnitude 2, and the nucleus activity subsided after mid-July, and then eventually it kind of turned the green color that you would see from that Comet 46P Worth-Tannen movie that I showed. And what I thought was pretty interesting too was this on the right. You see this is the path that the comet takes. It's a stereographic sky path projection, and each step between these dots, and the dots represent the comet and its sort of apparent magnitude, is 7 days. So from the time it was discovered back here in March, end of March, you can see its motion through the constellation. So this is, this is just one part of the, well, quite a large part of the, what's the word? Celestial sphere. And so you can see how it's moving through these various constellations from our point of view. And up here in July is when I guess I kind of heard about it. I guess I did hear about it in April, but I didn't really get serious about trying to look at, photographing it until well into July. So the red, this area where I circled here in red, those are the days where I actually got to go out and see it. And that's, as you can see, it was getting up, it was rising each evening. It was getting higher in the evening sky towards Ursa Major. So you could see it's kind of approaching and then passing by as you get into August. But I thought what was also really interesting about this is the entire orbit of the comet is just from our point of view. And because we're orbiting around the sun, you see these retrograde movements in the, these sort of loops, and it kind of goes down to almost infinity down here. So that's showing its complete path, its complete orbit as we would see it if we watched it over the course of 6,500 years or whatever. So I thought that was pretty interesting. And then this is more like what I was looking at when I was in the hunt for the comet. I was watching the news and I would see something like this. And so yeah, from the 15th through the 20th, those are the days that I three nights I managed to get out during those days, during that period of time where it was approaching the Big Dipper. And my equipment was fairly basic. On the left, you can see it's just really a DSLR with a lens on a tripod. That's what I used the first night, because I wasn't even sure I was going to go out, and I kind of decided last minute, so I just grabbed what I could get quickly and basically ran out the door. The lens is a 105 millimeter focal length macro lens, f2.8, and I had to put a dew heater strap on it to keep it from fogging up. The camera itself is just an older Nikon D50-300 that I had modified. It's the same one I used for pretty much, well, for all my images in my gallery, just using it with a lens here. And the tripod is just a photographic type tripod. I used my computer to control the camera. I just figured it would make the whole acquisition and monitoring of the target a lot easier. And I was used to doing that for just my normal, astrophotography stuff with the telescope. And yeah, so that was that setup. And then on the right, I used my mount. It was the first mount that I got. Not really suitable for astrophotography, but it was certainly able to handle this, just the camera with the lens. So that was my only other really option if I wanted to, unless I wanted to drag my G11 out, but I thought that was overkill. So I used this for the other 2 nights, and the reason being is I could then track the movement of the stars, and watch the motion of the comet against the stars. Whereas with the tripod, everything is moving, and you'll see that in a minute. And in terms of my imaging sites, I showed this at our astrophotography meeting we had a couple months back, and it was pretty clear that Halibut Point was the place to go, because I needed to be guaranteed that I could get a pretty good view to the northwest horizon, and that was definitely the spot. So that was almost a no-brainer to go out to Halibut. So in terms of where I actually set up, on the first night I just went straight down Garfield Ave when it turned into the sort of the trail, and I just kept going straight out until I got to the rocks here. And the reason was, when I got out of my car and started walking across, I could see the comet. I could literally just see it almost centered on, it was almost directly in this direction to the northwest. And so I was just so excited to see it. I didn't even think about going anywhere else. I was like, well, there it is. So I'm just going to walk straight until I get out to the water, and I'm going to set up. And so that's what I did. And then the second and third nights, since I had the larger tripod, I didn't really feel like going down to the rocks with it. So I just set up right on there's like a little, right on the corner here, there's this little open area that I just set up. Yeah, a couple, actually, like Frank joined me one night, and another friend joined me another night, just to try to get some images as well. But yeah, it was really exciting to be walking down there, and it's pitch dark, and you're walking down through the woods, and you just see the comet up in front of you, and it's just I don't know, it was kind of mind-blowing. So this was the first shot I got, or one of many shots, but they were single 7-second exposures. Going much longer than that I was just starting to get a little too much trailing in the stars. And I did kind of crank up the ISO a little bit, so it's ISO 3200. And yeah, I was still really thrilled to even just get that. So I basically set it to, once I framed it, I let it go, and I just took image after image on maybe roughly a 7 or 8 second interval. And then I did have to reframe it once as the comet moved across the frame. So I reframed it as it was dropping down below the horizon, and I just kept taking pictures, and I put all those pictures together in an animation. So here it is. I'll play it one more time. So what's cool about this kind of photography, or I guess with this goal in mind, is that the clouds and the satellites and the shooting stars and whatever other things are typically light pollution on a normal night for me are actually kind of part of the interest and kind of add to it. So it's a nice change. I'm not stressing out as much about seeing a passing cloud as I would be if I was, locked onto a single target, trying to take hours of exposures on one target to stack the images. So I knew I wasn't going to do any stacking, so I didn't worry about it. Then the next July 17th, couple nights later, I went back out, and this time with the tracking mount, because I could track the stars, I didn't have to worry about star trails, so I could take much longer exposures and turn the ISO down to basically improve the image quality. So I ended up getting taking 45-second exposures, still at f2.8. And I combined 8 of them to get this image. So I stacked eight of those images to get this one. Stacking beyond that, you start to get a little bit too much motion of the apparent motion of the comet, because obviously it's moving with respect to the stars, and the mount is trying to stay fixed on the stars. So I kind of found just through experimentation that a few minutes of exposures was about all I could really get away with for stacking if I wanted to have tight stars, or relatively tight stars. And I did still take all the images I had done in succession in a time lapse. It's a bit shorter because there weren't as many images, but this was really neat because again you're seeing the clouds are moving, the comet's moving against the stars, and it kind of really gives you a sense of what that this thing is really real. It's really moving across our solar system, and yeah, it's just so cool to see these come together like this. My last night out was on the 20th, and I ended up going a little bit longer on the sub exposure, so 60-second exposures. And I wanted to, I did that because I wanted to stop the lens down a little bit to get a little bit sharper. That particular lens isn't necessarily an astrophotography lens, so it does have a little bit of coma. And so I just, I wanted to make it a little bit sharper. So I found I could go to 60 seconds and it still looked reasonably good for sub exposures. And then I stacked about 7 minutes worth to get this image. And again, you can see I guess I didn't even talk about the previous one, but you could see the ion tail and the dust tail pretty clearly, and it's just remarkable how far they stretch. I'll just go back 1 second to the other one because it actually almost goes clear across the frame if you look really closely. Like the ion tail almost goes all the way back. And if I wasn't at Halibut Point, I definitely wouldn't have gotten this. So it's just a great place to be able to get to in a reasonable amount of time to get images like this. So yeah, that was a little bit more exposures on this one. So I got a little bit longer of a movie out of it. And again, you can see it moving through the clouds and and moving against the stars. And I think that's all I have for pictures. I do have the movie the little video I made. I could play that now because it just puts everything together, and it does have some GoPro footage I took at the end, and actually I had about an hour just on the Milky Way after the comet had kind of dropped too low in the sky. So it has that in there. So I'll just play that.
You need to enable the sound on your system. We're not hearing anything.
Oh, sorry about that. Let's see here. Remote.
Is it playing through your headphones?
It is.
Try unplugging your headphones.
Well, my headphones are part of my headset. Like I'll lose my microphone and everything. It's like a USB headset. Oh, share computer sound. Let me try that.
There we go.
You hear it now? Okay, so I'll back it up a little bit. Sorry about that. Oh, whoops. Sorry about that. Let me go back. I must have clicked on something. Hold on. I'll go back to. So that is, yeah, that's it for that. And then I think that's it. I think that's the end.
Wow. Thank you, Jeremy. I'm going to unmute everybody. That was terrific. You know, my monkey brain keeps telling me that the comet should be moving in a particular direction given its tail, and it always moves sideways.
Yeah, I know. Yeah.
It's very counterintuitive the way those things move through the sky.
Yeah, I thought so too.
All right, do we have any questions for Jeremy? Comments?
Jeremy, this is your dad. I was just remembering that this is what you had put up on your channel, right?
Yeah, exactly.
Yeah.
Yep.
So the sounds and the pictures, the video, the astrophotography and all that is what you put together in your studio, right?
Yes.
Okay.
You have a future. You have a future in this business. If that was your first attempt, you have a future in this business.
Thanks.
You gave Rockport photo credit. You don't see that every day.
Yeah. Well, it's more people should know about it. Yeah.
Jeremy,
Perhaps-
this was really great.
Perhaps Halibut Point would be interested in a picture which they could eventually post at their visitor center.
Yeah, that's
Sure.
a good idea.
Yeah. Happy to share.
I'll broach that topic for you with the manager there. We get along very well with him. Something may very well come of that if you're willing.
Yeah, absolutely.
Do you know how close it came to Venus?
Um,
It looked fairly close in that orbital
right.
Yeah,
animation.
it was way north of the ecliptic.
Oh,
I always appreciate that in a comet.
It has to cross it sometime.
I think Mercury's a nice spot.
Yeah, it looked like it came close to Mercury's orbit when it crossed the ecliptic. It's just that Mercury was on the other side at the time.
Mercury's tough. It could take it.
So how long has it been for us in the Northern Hemisphere to enjoy something that is readily naked eye, a comet like this?
I'd say Hale-Bopp and
Hale-Bopp.
Hyakutake were the last two really good ones.
95, 220,
Late 90s. Yeah.
20 plus 5, it's 25 years.
This is the first comment in my lifetime. I didn't get to see Hale Bopp when I was a kid. So this is really cool to see.
Yeah, I don't know.
25 years and a lot of people still can't say Hayakataki.
That was my favorite comet. I got a great image of, it was 160 degrees, went from one horizon to the other. I've never seen a comet like that, ever.
Oh.
Wow.
I was intrigued by several of your graphics. You had a really interesting graphic on magnitude that went from, I don't even remember, but it was a really wide spectrum of
Right.
magnitude. And that was very interesting. I'd be interested in getting a copy of that.
Oh, sure. Yeah, I could send it.
And then
Where you got, when your stuff is online, you know.
All right, well, Galaxy 7332 and 339 are beckoning me, so I got the dome open, ready to go. So I'm going to say
Bye,
good night
Mario.
to everyone.
Thanks for coming.
Take
Good
care.
Good luck.
Bye.
Clear skies.
Jeremy, I have a question about the music.
Sure.
Were the drums done by you as well? Did you combine that?
I programmed the drums. I did not play them.
Okay.
I do have a drum set, but I didn't have time to. Yeah, I'm not that good of a drummer.
Right.
So you're out of service for how long till you get your equipment back?
That's a good question. It really depends on what happens with the Moonlight focuser. That's kind of the culprit for my collimation issues. So Stellar View is talking to Moonlight, and they're going to let me know, I guess. So it could still be a few weeks.
Hopefully you could do some wide angle nebula stuff. All the nebulas are good with the camera lenses.
Yeah, I could use. I have a couple lenses that might be okay. They have a bit of coma, so they're not great, but I could stop them down and do something.
We got a couple of small telescopes you could borrow.
Oh yeah.
Oh yeah.
Okay.
Some 80 millimeter f5s, a couple of those, and we have a Frankenscope, which has to be seen to be believed. Seriously, a nice 60 millimeter f6 point something.
Nice.
I have a question about accessing this presentation again. If I wanted to find GAACsters and your videos, where would I look?
Well, it would depend on where we post them. Still shots go in the galleries on the website. We could actually try posting videos up there. I don't know that there's a restriction on file types. They might work. I just don't know. I've never tried it.
Well, I'm happy to share the presentation if you want the actual PowerPoint slides. I can
Okay.
Well,
share those.
no.
We could host that on the GAAC server. There's no problem with that. If you are agreeable to that, we could just send the link.
Now I got to buy a membership. I know this is part of your marketing campaign.
Well,
I'm
we
kidding.
want to make your membership fees count every dime.
Yeah, and I should start paying my own way. I mean, come on.
But the actual recording of this meeting, including Jeremy's presentation, should be easily accessible. Could
Yeah,
be
this
easily
probably,
posted.
I think we know where we could publish this, Bill.
Yes.
We could publish this on the Galactic Inquirer
Right.
as a YouTube video.
Sure.
And with your permission, Jeremy, that might be the best thing to do. People would have to put up with our chit chat, but that's okay.
Yeah, no problem.
And I would also like to work with you on a second presentation,
Okay.
taking what you have and turning it into a theatrical event.
Oh, okay.
Yeah.
Wow.
Will there be costumes and dancing, Jen?
Yes, you have to come as a rhinoceros. But
He
a
plays a
very
great
wise,
cockroach.
a very wise rhinoceros.
All right, well, then I'll accept that. All right, I'm not sure who we have for October. I think, Phil, you're up for November here, right?
I'm November,
You're November.
right.
Is anybody here online for October? I'll check our list. I'm sure we put somebody in there, but I can't promote it right now because I don't know what it is.
Unless you want to move me up to October.
We'll talk about that. If it's an
Yeah.
emergency, we might.
Yeah, I mean, I'm planning on November, but I'm all set to go,
Okay.
as you know.
Yeah, you seem to be. All right, folks. If you want to chat, we can sit around and chat, or I can turn out the lights and we could go observing.
Yep.
I'll say goodnight.
All right, folks. Thanks for coming. Jeremy, thanks very much.
I'd like
A polite round of Zoom
Sounds
applause for you.
Thank
Thank you,
Thanks a
Jeremy.
lot.
Jeremy.
Great presentation, Jeremy.
Thanks,
Very
Jeremy.
All right, great job, by the way.
Thank you
Thanks,
so
Jeremy.
much.
It was
All
great.
Thanks,
right,
Mike.
folks. Out go the lights. Good night.
Thank you.